Hey everyone, can you believe it's week 3? I hope you had a good weekend. This lesson 7 is going to be about a new method for solving quadratic equations. I wanted to do a pre-thinking activity first though. So I have this expression here, x squared minus 10x plus 25. And it's an expression because we don't see an equal sign, right? And if we recognize it is in this format, what format is that? Well, it helps to have a little tool chosen first. Second, that's in standard form, right? Now, when an equation is in standard form, what information does it give us? Which intercept? Y-intercept, right? And we know that to be here. So since it's positive, that's 25. Y-intercept is when x is 0. And if we took that expression and turned it into an equivalent one so that it mirrors this, it would be in factored form. These are number factors of this binomial times this binomial, 1 factor, 2 factors. And the information factored form gives us right here roots, right? And since this is subtraction and this is subtraction, I can just use this number 5. Subtraction 5. So I'm going to write down roots. Roots, hopefully you remember, are x-intercepts, and that is when y is 0. And since this is the same number, I can just write one of them. Okay. Over here, the format that we have that's equivalent is in vertex form. And it gives me the vertex when we have subtraction here. And must be plus 0. And so this vertex, if you recall, is hk. When it's in this form, since it's in subtraction, vertex is going to be 5. And plus 0. Now, can you think about why these are the same? Must be, if we do a little sketch of it here, right? It only touches the x-axis at one point at 5, 0. So there's only one solution when x is 0, right? Sorry, when y is 0. Okay, hopefully that little quick review will get you thinking about the next section. Let me see if we can get there. I'm really tempted to do a new video clip right here, but I'm not going to. I'm just going to move on here. Stay with me. Okay, so now we have an equation, right? Let me get this back. Or now we have this equal sign, right? So what if we were asked to solve this equation? So the only method that we've talked about so far is what you did last week. And do you remember what it was called? Square root method. And in the square root method, we just tried to get x squared alone, right? We just wanted to isolate the variable, and because it was being squared, since it's quadratic, we could do that. But there's a problem, right? Which x are we going to try to isolate, right? We've got 2 of them. So this was what was missing last week with that strategy we used. That square root method only works when there's no b value. That the only variable is the x squared, okay? Okay, so well, what do we do about that? Is it a perfect square trinomial? Yeah, right? And so if it's a perfect square trinomial, can we express it as a square? What form would that look like if it was square? Well, we had it in the previous page, right? Right? This would have been A. So what form is that? Vertex, right? So in vertex form, this was x minus 5 squared, and we didn't have anything to add right there. But it's an equation now. Okay. All right. Well, can we use that square root method now? I'm just going to abbreviate because my handwriting's so bad with this stylus. Can we use square root? Can we try to undo squaring? Well, yeah, instead, though, of isolating x squared, we're going to isolate this binomial squared. X and whatever number we have there. We'll say A. We're going to isolate that. So is it already isolated? Am I multiplying it by A or anything? Adding anything, subtracting? No, right? It is alone. That binomial doesn't have anything, other operations happening. It's just this expressed as a square. So undo squaring, square root, the whole square expression. And if I do it to one side, I have to do it to the other. So this is the side of the square. Remember, maybe the length and the width. I'm just going to find the square root of the whole side. So these are going to cancel each other out, right? And I'm going to be left with x minus 5 equals 8. But what do we not want to forget? Both of those. Both of those are important to remember, okay? Okay, so I'm going to move this down. Sure, we'll see if it lets me. Yay, okay. Go back to getting a pen here. And the trick here is obviously we're going to have two solutions, right? So I'm going to solve this two different ways because x minus 5 could equal 8, but x minus 5 could also equal negative 8. So we go through our solving process, same for both of these, right? Add 5 to both sides. And we could do it over here, add 5 to both sides. Sorry. And what do we get? X equals 13. Or x equals negative 3. Now here, I can write my solution. I like to do them in order. This is going to cross the x-axis at negative 3 and at 13. So those are the zeros, the roots, the solutions when y is 0. So we did, if we were asked to express this with our intercepts, right, it would be negative 3 and 0. That's one intercept. Okay. And 13 and 0 is the other intercept. Now, hopefully all that makes sense. I want to just point something out up here. Let me go back up here. Here, we thought there was one solution, right? Just because the vertex and the roots, right, were the same. the vertex and the roots were the same. But remember that this is when what we're assuming this whole time, and nobody really knew it because we were just talking about expressions, was that all of these were equal to 0. If you didn't see y, we assumed it was equal to 0. When we did this example, sorry, let me move it. When we did this example, it was equal to 64. And so when that expression is equal to 64, that's when we would get these two solutions, okay? Remember, this is called set notation before I forget. So this is our set notation. And over here, where I wrote them as ordered pairs, that's just intercepts, right? Ordered pair notation. Can be tricky, right? Because we tend to think of x and y. But this is root 1, and this is root 2. Okay, well, that's just some pre-thinking to get us started with this next lesson about solving, still using the square root method. It's just that we're going to use it with a vertex form.